Hello, and welcome to today's daily Leetcode challenge. Today we'll be solving question 1503, last moment before all ants fall out of a plank. Okay, so bit of a weird name there, but we have a wooden plank of length n units. For some ants walking on the plank, each ant moves with a speed of 1 unit per second. Some of the ants move to the left, others move to the right. To purely visualize this, just imagine just like a wooden block, a one-dimensional wooden block, and ants moving in either directions somewhere there. When two ants moving in different directions meet at some point, they bounce off and they go in their separate directions, assuming changing direction doesn't take any additional time. So they would just be bouncing back and forth. When an ant reaches the end of the plank at time t, it falls out of the plank immediately. Given an integer n and two integer arrays left and right, the position of the ants moving to the left and right return the moment when the last ant falls out the plank. Okay, well, I mean, I guess there's two different approaches to here, and I'm guessing the hint shows probably one of those approaches, but the harder and the more intuitive approach is to simulate this interaction of all the ants, right? So you have the position for all of the ants starting out in the left and the right list arrays, and what you're able to do at that point is have like a while loop, or maybe not a while loop, while left and right, while they're not empty. And inside of that loop, try to simulate how the ants will be bouncing off each other and walking off the plank. However, that would require you a lot of different condition tracking. You would have to see if an ant is one position away from an other ant traveling in the opposite direction or towards it. In this case here, I can see that A, B, C, D, B, and C, they meet, and at time 1, they have seemed to turn around, and then B bounces against A, and then bounces against C again, and then goes back into their separate directions. So, for example, in this scenario, simply when we have 4 ants, 2 starting going left, 2 starting going right, B and C bounces together 1, 2 times. B bounces against A once, and basically it turns to be very, very, very difficult. However, if you were to notice the output 4, the output is 4, so it takes 4 seconds, 4 units of time for the last ant to walk off. And we can see that B and C are the ones that are walking off last. So 1, 2, 3, 4. Basically, I guess in the hint here, it breaks down this seemingly complex problem into a very intuitive and kind of easier approach to this, and that is just to imagine that that when the ants meet, the process of them bouncing back and going into their separate direction is sort of equivalent to them not changing where they're ever going ever, and just going their own separate ways from that point. So imagine now that when B and C bounce here, it's not that B changes direction and starts moving the other way, and neither does C. They simply just pass each other and they morph into themselves, into each other respectively. So B turns into C, C turns into B, and then you can pretend that B continues going into C here, and C then turns into D when it bounces against him, and D walks off the plank. So all of a sudden, B has morphed into C, then morphed into D, and D walked out at some point, right? Let's see when did D fall out? Well, D is here at the fourth position, then it's in the third position, then D morphs into C at 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 position 2.5, then into B, then into B, and then into B. So D actually turned into B. What am I trying to say here? I'm trying to say that it's possibly enough for us to just know what the different positions of these ants are if we are able to apply this morphing analogy. And in that case, we could say that, hey, it actually just takes the max, or the ant that's going to walk off last is the one that's initially furthest positioned from the edge, moving in the edge's direction. So for example, it would be either D or A. Let me code this quick, because this is actually pretty much like 3 lines of code, and then maybe it'll make more sense. Max time, it's going to be equal to 0 for pause in right. Let's do left first. Time is equal to max pause max time, and then same thing here, except here I'm going to be saying n minus 1 and return max time. See if that works. Awesome. Basically, what did I do here? I've looked at all the max positions in the left moving array from 0 to 4, and then I did the same for right moving positions from n minus the position itself. And that really is figuring out which ant is furthest away from the edge. That's it. Let's submit this. See if there are any edge cases. There is an edge case. That's what I meant to do. There we go. My bad. And yeah, we're beating 97%. This is probably the only solution. Oh, there's some cleaner ones, but this one is very intuitive, and yeah, just use this. Very simple, makes sense, and it's very clean, easy to understand. All right, with that, thanks for watching. Please like and subscribe. I'm trying to do November daily, so perfect. See you tomorrow. Bye.